In this video, I wanted to talk about some notation when we looked at separable equations. So I have this example here. We were asked to solve dy dx is equal to 3x squared plus 4x plus 2 all over 2y minus 1. So your book probably has something like where it looks like they almost cross multiply. So 2y minus 1 times dy is equal to 3x squared plus 4x plus 2 times dx. And then you integrate the left-hand side with respect to y, and you integrate the right-hand side with respect to x, and this is the solution you get. Whereas when I do my problems, what I have is I multiply both sides of the equation by the denominator. So I'm going to get 2y minus 2 times dy dx is equal to 3x squared plus 4x plus 2. Then I integrate both sides of the equation with respect to x. And then what I get is, again, this is dy dx. Since I'm integrating with respect to x, when I take the derivative of this with respect to x, I'm going to get my 2y minus 2, but also both of these y's are functions of x, and that's where my dy dx here is multiplied by both terms. And the idea is, the way I do it, it almost looks more complicated. You've got all this dy dx, but it really is the same thing. Among other things, the similarity or the reason why this is actually the same thing as what I've written is because by the time you're here, you can kind of cancel out the dx's, and so you get basically the same exact equation. But the reason why I like to do it with these extra steps in there is because here it isn't obvious to me. If you have two things equal, you can integrate with respect to y on one side and dx with respect to x on the other side, and it's okay. But in this case, it does happen to be okay because of the way that this works out. It's actually equal to this. And the last comment I want to make is this dx here, this dy, it does actually stand for something. It's not just simply notation to let you know you're taking the integral with respect to x or the integral here with respect to y. And what does it stand for? You remember when you first learned how to integrate and you did those Riemann sums? And so you summed up, if you had some curve, you had you divided your interval along x into equal parts or whatever, and then you either took the midpoint or maybe the max or the min, and this was f of x. The height was f of x, and then here the width of your rectangle was delta x, remember? And then you would do that for x sub I, because here if you divide it up into three portions, you would have x1, x2, x3. And then what you did is you then took the limit as delta x approached 0, and that's how you came up with the definition of your integral. And so the thing about your integral is this dx, that stands for the width of your rectangles, the section that you're actually taking the area of. So it is an actual thing. It's not just notation you can throw in when you feel like it. Okay, that's all I wanted to say about this, just why this is actually equivalent, these two statements are equivalent, and why I like to look at it in this sort of way. Thank you for watching.